I am Anil Kumar. Welcome to my series with Aryan, a grade 8 student doing grade 11 mathematics in USA. In this particular video, we'll discuss questions related to the bearing angle. Now in trigonometry, you understand what is sine law, what is cosine law, and you must have done many applications. However, the most tricky of these are the ones which involve bearing angle. We are going to look into those. So this series on bearing angles will be divided into two parts. We'll first deal with examination style questions where the figure is given to us. And then in the second part, we'll take up examples where you have to sketch the diagram also. Now that requires a deeper depth in understanding a real life situation. I hope this video will help you get the concepts and solve similar questions without any difficulty. So watch the video and enjoy. Hi Aryan, how are you doing?
Yeah, I'm doing good. How are you?
Very good, very good. So today what do you want to do?
So in today's class, I think we could maybe start trigonometry, not start, but like dive deeper in trigonometry identities and bearing problems.
Correct. So you're almost at the end of the session. You know quite a few concepts. It's kind of a review time for you, right?
Yeah.
Okay. So you shared some questions on my drive. So let's look into those
Okay.
and select some of them. Yes. Can you please read the question?
Yeah.
It was a long question. Okay. Let's see.
Yeah.
Yeah. Read.
The diagram below, which is not drawn to scale, represents the positions of three mobile phone masts. Mast Q is on a bearing of 100 degrees from mast P and is 40 kilometers away.
Correct.
The bearing of mast R from mast Q is 150 degrees, and mast P and R are 66 kilometers apart. Use yeah.
Use the information in the diagram to establish the size of the angle PQR. So we have to find this angle. Right. So the diagram is well labeled, right? Now, if this is 100 degrees, how much is this degree? Tell me.
80 degrees.
Correct, because they are complement. 180, they form a linear pair, correct?
Yeah.
Two parallel lines, and these are inside angles. Okay,
Yeah.
80 degrees. You know that is 150 degrees. How much is this? 360 minus 150 minus 80 is that angle PQ.
Yeah. 2 times.
Minus 150 minus 80. How much do you get?
230.
230. So 8 plus 3, 11 and 5, 16, 360. Yes, you are right. So 230. So we have done the first part. Second, hence find the bearing of mast P from R. So from R, we have to find the bearing of P. Correct?
Yeah.
Right. So that means from R, bearing of P will be this angle. Do you understand? We are interested in this angle. Do you understand?
Yeah.
It's always from north.
Okay.
So that is the angle you want to know. So you can use which trigonometric, sine law or cosine law to figure it out. We know one combination which is opposite, so we can find this particular angle. Let me call this angle as theta. Is it okay?
Yeah.
So we'll use the sine theta over the side opposite to it, 40 equals to sine of 230 over 66. Is that clear to you?
Yeah. And then we just solve for theta.
Oh, it is 363. You did this is 130. Sorry, not 230.
Yeah. That's my fault. Yeah, 130.
130. Correct. So now We know sine theta is just cross multiply, check. What angle do you get? Sine theta is 40 over 66 times sine of 130 degrees.
Yeah.
So how much do you get? Theta is sine inverse of all this, correct? So
Yeah.
what is the angle?
It is 1 second. 27.66 or just 27.7 degrees.
27.7 degrees. So we get this particular angle theta as 27.7 degrees.
Yeah.
Now we know that angle is 27.7. Now if this is 150, look at the diagram once again. If this is 150, how much should this be? 30 degrees, correct?
30. Yeah.
So we know that angle. So 360 minus 30 minus 27.7 is your answer, right? So bearing angle will be, let me change the ink.
Yeah, it should be 302.3 degrees.
So we have to do 360 minus 30 degrees and minus
27.
27.7. And we get our answer. Do you see that? What is your
Yeah.
answer? Approximately 60. So 300 something, right?
Yeah, 302.3.
Perfect. That is what you get. Is that clear to you?
Yeah.
Any difficulty?
No, 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 no.
Perfect. So we just got this one. We will now look into the next question. Where is the next question? Okay. Perfect. Can you please read this question?
Yeah. A par 3 hole on a golf course. The tee is a distance of 130 meters due west from the pin.
Mm-hmm.
On his first shot, Bruce hits the ball 100 meters but not at the correct angle.
Mm-hmm.
On his second shot, he hits the ball 35 meters and gets in the hole. On what bearing A did he hit his first stroke?
Correct. So you're given three sides of a particular triangle. You need to use cosine law to find the angle, correct?
Yeah.
So it says a par 3 golf course is a distance of 130 meters due west. So when we are saying due west, that means this is 90 degrees. Is that okay?
Yeah.
Because this is due west.
Yeah.
So from north it is due west, that means both are 90. Is that clear to you?
Yeah.
Oh, that's good information which we have. Now due west from the pin. Use cosine law to find the angle, and the angle which you should find is this angle, because then clearly we can get our answer straight away, right?
Yeah.
So let's call this angle as theta. So what is cos theta equals to?
It is equal to
1100 square plus
100
130 square
squared plus 130 squared.
minus
130.
35 square
Yeah.
divided by 2 times.
130 times 100.
Yeah. Do it and then find theta. What do you get this value as? Calculate.
Yeah.
Have you done the calculation again?
Yeah, it's first said error, so I'm just doing it again.
I'll,
I'm just
so
plugged in.
basically, we have cos theta. This is the angle theta which we are looking for. Cos
Yeah.
theta is equal to 100 square plus 130 square minus 35 square divided by 2 times 100 times 130. Is that
Yeah.
okay? Let's
Yeah.
calculate.
Yeah. For that angle, I got 9.07.
Oh, then it is okay.
Yeah.
So we do this, and then we do theta equals to cos inverse of all this, correct?
Yeah.
And you get 9.07. And alpha will be 90 minus 9.07. What do you get?
you get this. Yeah, you just yeah. So yeah, so in the answer key, I think they just rounded to the nearest integer instead. So yeah, but you should just get 80.93.
Okay. So that is the angle, but you have to report the angle. When you write in bearing, it's 3081, you can round, right? 081 degree. Is that okay?
Yeah,
Bearing angle always should be written in three places. Okay,
yeah,
so that is how you're going to do it. So it was 90 because it is due west, right?
yeah,
That is it. Okay, so we'll move on to the next question.
yeah,
We got quite a few questions here. Yes, can you please read the question?
yeah. Okay, a helicopter sets out from its base P and flies on a bearing of 123 angles to point Q,
Mhm.
where it changes course to 60 degrees and flies 18 kilometers to point R. When the kilometer is at when the helicopter is at point R, it is 22 kilometers from its starting point.
Mhm.
Find the size of angle PQR and calculate the bearing on which the helicopter must fly to return directly to its base. The shaded angle in the diagram.
Correct. So you have to find PQR. So in this particular case, what this is 123. So you can find the other angle, which is 180 minus 123. How much is this angle?
Yeah.
What do you get? 180 minus 123. $57, right?
Yeah. So then the whole angle is 117.
Yeah. So
Yeah, I think I found the shaded angle.
this angle, and this angle, right? So
Yeah.
these two are not, and this is going 60, and this is 120. Is it okay?
Yeah.
You have to find that small angle also.
Yeah, we could just use law of
Find
sines
the
or
size of angle PQR. So what is PQR?
117. I just used law of sines to find angle QPR.
Yeah, because this side is no, and then you could do minus. Correct.
Yeah, and then I got 46.8
You are
for
correct.
that. So I just rounded to 47.
Correct. So find QPR. That's correct. So let's say this angle is phi. Okay. So we say
Okay.
sine phi over 18 equals to sine of 117 over 22. So from here we calculate sine phi equals to 18 over 22 times
Yeah.
sine 117. So find phi from here. Phi equals to sine inverse of all this. You got how much?
Yeah, so I got 16 degrees for
Okay.
that angle.
So you know theta is
Oh, no, theta is 16 degrees. The
okay.
angle QPR is 47 degrees.
This is 47 for you. Okay. So that is 47. Then it is 180 minus 117 plus 16 degrees. Oh, plus
No,
40.
no, it's 47. Yeah.
57?
No, 47. Yeah, it's right. It's right.
47 degrees. So that gives you how much?
You get 16 for
16.
angle theta.
Okay. So if you know this is 16 degrees, you can now calculate the whole thing, correct?
Yeah.
360 minus, so R is, bearing angle is, I'll write it.
Yeah.
360 minus 120 and then
120.
add
Yeah.
16. 16. You
Yeah,
get
so this is minus 104.
and then you add 16, right? So you get your answer.
Yeah.
So that is all. How much do you get?
It says 256.
That is your answer. Is that clear to you?
Yeah, it's
Good
clear.
job. So if you don't, so as you did correctly, you can find the other angle and then do this to get the right angle. Correct. So let's clear this and go to the next question.
Yeah.
There you go. Yes, tell me. Read the question.
Okay. Yeah. Brampton is 70 kilometers due east of Abbott. The bearing of Corwood from Abbott is 15 degrees, and from Brampton is 290 degrees.
So the bearing of Corwood from Abbott is 15 degrees. So this is 15.
Yeah.
And from Brampton is 290 degrees. The bearing of Corwood from Abbott is this, and from Brampton is 290. That is 290. You get the idea. From
Yeah.
Brampton to Corwood. You get the idea, right?
I have one little doubt.
Yeah, ask.
Yeah, so it says, so how do you know that the angle is also like a part of the triangle? If so, I might, it might be a little weird the way I'm saying it, but the 290 degrees is also is also like, there's also like a part of the triangle angle that's in it. So how do you exactly know that that is in it? Because yeah,
One thing is, the way the diagram is made, it doesn't really give you, it gives you like a 3D effect. Do you see that? But it's not a
yeah,
3D diagram. Strictly speaking, the north is kind of like this, right? That is the
yeah,
north, right? So we are looking at this kind of a thing. So north is inside the plane. Now, when we say the bearing of Corwood from Everett, so from this point, the bearing of that point is 15 degrees. So that is from north, you measure the angle.
yeah, okay,
And the bearing of Corwood from Brampton. So from Brampton, you have to measure from the north, right?
yeah, yeah,
And the path is this, land of
okay,
angle path.
okay,
Get the idea? So
yeah,
that is how it is. So it goes through the triangle. It goes through the triangle. What can we do?
yeah, yeah,
So that is how it is, right? So this angle was kind of like this. From here, it is all the way to this point. That is how it is. Is okay?
yeah, that's okay.
So 290. Now let's fill in the other angles. We know what this angle is. 180 minus 15. Do it.
It's, yeah, just 165.
165. So likewise, we can get other angles. So if this is 290, how much is this? 360 minus 290.
70.
And how much should that be? 180 minus that.
110. Oh wait.
Now let's
Yeah.
take it further. Make a neat copy of the diagram and fill in all the three angles inside the triangle. So now let's work out the inside
Yeah.
triangle. We know this is 15 and that is
That's
90 degrees.
75.
So this is how much? 90
70.
minus 15.
That's the 75 degrees.
Correct. We know one side. We know the other angles. Correct.
Yeah.
We know this angle. How much is this angle? Do
85
180
degrees.
minus all this.
85 degrees.
Yeah, 360 minus all this, right? 85 degrees. So we know this angle also, right?
Yeah.
180 minus add them.
Yeah. That's just 20 degrees.
So that is how we get all the angles, right?
Yeah, and then
Calculate the
calculate
distance
the-
between Corwood
yeah.
and Brampton.
Law of
You have to
sines.
find this distance, right? Yeah, you can use law of sines, right?
Yeah.
So we can say, let's say this is x, right? So we have x over the angle 75
Yeah.
equals to the given side is 70 over sine of 85.
Yeah.
Find x. What do you get? Yes.
Yeah, 67.87. It is 67.9.
Okay.
Yeah.
Units, kilometers.
Yeah.
Okay, that's fine. So we get all this.
Yeah.
Is that clear? I hope you have understood in part 1 how do we solve bearing related trigonometric questions when the diagram is given to us. And now, let us take up examples where we need to sketch the figure and then solve the question. I hope you find them interesting and useful. Start from here. Bearing
Yeah,
of
this is a fun one.
yeah.
Yeah. The bearing of a buoy from a ship 8.7 miles away is north 64 east. The ship is headed due north, and the navigator plans to change course when the buoy has bearing of south 26 east. How much farther will the ship travel before a change of course is needed?
Okay. So let's make a diagram here. We'll make a small one first.
Yeah.
The bearing of a buoy from a ship 8.7 miles away is north 64 east. So from north 64 east, bearing of a buoy from. So we'll keep this point center. And from
Yeah.
here, from north 64 degrees east, we'll go like this.
Yeah.
So bearing of a buoy, so we'll say this point is B.
Yeah.
From a ship 8.7 miles away is, this is 8.7, and this
Yeah.
is ship. The ship is headed due north. Ship is going north.
Yeah.
And the navigator plans to change course when the buoy has a bearing of south
South.
26 degrees east. So from south 26 degrees east. So let me just use another info.
Okay.
So from south 26 degrees east. So that angle is given to us as 26. Do you understand?
Okay. Yeah.
How much further will the ship travel before a change course is needed? So we have to find this distance. Let's say this distance is A, right?
Yeah.
SA is what we need to find. So in this particular case, you are given one bearing, which is 64 degrees. So we have two angles. We can easily find the side, right?
Yeah.
First, find the third angle, which is,
Isn't it 90? Isn't it?
is it 90? Okay.
Yeah.
Okay, okay. So that's 90. How come? Okay, 90. So you can find this side, correct? That's simple now. So you know the base. You can use any one of these angles and find it, correct?
Yeah.
Okay, so what answer do you get? So do you want to make a new diagram for this?
Uh, 19.85.
So what we figure out, let me just make a new diagram.
Yeah.
And this was 64 degrees. This was 26 degrees. And this side is given to us is 8.7. And we have to find this length x. Clear, right? So in this particular diagram, if you go through angle 26, you can use sine. Correct?
Yeah.
Sine of 26 is 8.7 over x. So x is equals to 8.7 over sine 26.
Okay.
How much
Yeah. And then you just get 19.85.
miles? So that is how you're going to solve. Correct?
Yeah.
Now let's look into the next example. Yes, can you please read the next example?
Yeah. A pilot of a San Antonio to Houston express plane traveling on a course of north 79 east sights the Austin airport off the left side of the plane. His line of sight forms a right angle with the plane's line of travel. Find the bearing of the Austin airport from the airplane.
Okay. So a pilot of a San Houston Express plane traveling in a course of, so this is the course, 71 degrees east, sights the Austin airport off the left side of the plane.
Yeah.
Let's see. His line of sight forms a right angle with the plane's line of sight.
Yeah.
Find the bearing of Austin airport from the airplane.
Yeah.
A pilot San Houston expresses plane traveling on a, off the left side of the plane. His okay.
Yeah. And then next 90.
So what is the bearing of this angle? So bearing will be,
Yeah.
how much will that be? 79. Yes.
That's 79. Yeah. I think maybe we should just redraw our skill.
Okay. So yeah. So basically the bearing will be from here to
Yeah.
that will be the bearing. Is it okay? So add 270 to 79 to get the answer. So
Okay.
180 plus 90 plus 79. So bearing will be 79 plus 270.
Okay. No, no. Is it? Yeah. Okay.
You understand?
Yeah, I got it. 349.
Because that is 90 and this is 180, so you'll add this. Is that clear?
Yeah. Yeah, that's clear.
Next question.
Yeah.
These problems are tricky, sometimes when you,
Yeah. That's why I wanted to go over them.
yeah, it's important. So, yeah, can you please read the next question?
Yeah. After the plane in problem 2 travels 45 minutes from the first sighting of the airport at 180 miles per hour along the same course, the airport has a new bearing of north 80 degrees west. How far is the plane from the airport?
Oh, this is continuation with that one. After
Yeah.
the plane in problem 2 travels 45 minutes. Okay, so basically it was, let's redraw this thing. So what we had figured out is that this was going at 79. So it continued, right?
Yeah.
So somewhere in between, we found that this was kind of like this,
Yeah.
right? And we did figure out that this particular angle, let me draw north with yellow line itself. Right. So okay, great. So it says, um, after the plane problem 2 travels 45 minutes from the first sighting of the airport at 180, so the rate is 180 miles per hours. So the distance travels for 45 minutes. So the distance is 45 minutes is 3/4 of an hour, right? So
Yeah, yeah.
3/4 of 180.
180. Yeah.
Right. Is it clear?
Yeah.
So multiply and then get your answer. 45 times, correct? How
Yeah,
much?
yeah, that's right.
How
That's my
much do you
fault.
get this?
Yeah. You get 135 as your distance.
Okay. So allow me, the airport has a new bearing of north 20 degrees. So after doing that much of time, which is 135 from here, north 80 degrees west.
Yeah.
So now from north it is 80 degrees west. You get the
Yeah.
idea. That becomes our scale. Then what do you want? How far is the plane from the airport? Okay.
Yeah.
So
So you want that whole distance.
we have to find this distance, basically. Correct?
So yeah, this basic law like sines and
Yeah,
cosines.
yeah, yeah. So that should not be difficult. So we can now figure out the angle. We know this side.
Yeah. And then just use law of not law of sines, this sine law or cosine law.
Yeah. So this is 79. With north, it is still 79. But that angle is 80 degrees. So how much is this angle?
That is 80 degrees.
No, no, no. It says
Oh wait.
north 80 degrees west. So you'll do 180 minus
Oh
80.
yeah, yeah. I thought you meant the other. Yeah, yeah. My bad.
You do 180. This angle is, let me use another.
180 minus 80 minus
Yeah.
79.
180 minus 80, that is 100,
One. Yeah.
minus
20.
79,
21 degrees.
21. You get the idea, right?
Yeah. Yeah.
So that is 21 degrees, and we know that is at right angle. And so we can find the hypotenuse knowing this, right? Using cosine. Is it
Yeah.
clear?
Yeah. Yeah.
So,
That's fine.
so the angle, this is like hypotenuse. It will be cosine of 21 degrees.
You should get
That is
144.6.
135 over x.
Yeah.
So x
Yeah.
is equal to 135 over cos of 21. How much do you get?
144.6.
Correct. So that is how you're going to find the answer. Is that clear to you?
Okay. Yeah.
Okay, so we're done with this question finally.
Yeah.
Let me clear this. Let's go to the next question. Question number 4. Can you please read this question?
Yeah. The navigator of a ship on the north 44 degrees east course sights a buoy with a bearing of south 46 east. After the ship sails 15 kilometers along the same course, the navigator sights the same buoy with a bearing of south 12 degrees east. Find the distance between the ship and the buoy at this time of each sighting.
Correct. Each sighting. So navigator of a ship on a north. Let's again make a diagram. Make this bright. So
Yeah.
north 44 degrees east. Sights a buoy with a bearing of
South
south
46 east.
46 degrees east. Somewhere here. South
46
degrees
degrees.
east. So from south, 46 degrees east.
Wait, so how do you know it's from that exact point? Wouldn't it be at the very, like,
Yes, any point. Take random
oh,
point.
that's right. Yeah.
Any random point. We
Yeah,
don't
yeah,
know.
yeah.
Yeah. After
That's
the
right.
ship sails 15 kilometers along the same course, so now 15 more kilometers, right? Navigator sights the same point at a bearing of south 12 degrees east.
Yeah.
After it says, so that is the point, right? The same point now is, let's just
Yeah. It's south.
12
Yeah,
degrees.
south degrees.
That angle now is 12 degrees. You understand?
Yeah.
And this is 15, correct?
Yeah.
Let's say this point is A, that point is B. So that's our triangle. You
Yeah.
get the idea?
Yeah, I get it.
So it is better if you draw a bigger diagram. It can
Yeah.
help you, right? So can you
Yeah.
do this?
Yeah. Yeah.
It's
So
good
this,
to draw a bigger diagram, right?
yeah, that way we can see it better.
Yeah. So after some distance, this just a bigger diagram, but nothing to do with the scale.
Yeah.
So we are given this angle initially is 40. We are doing 44 degrees, right?
Yeah.
44 degrees.
Yeah, it's 44 degrees.
Size of south 46 degrees. From south 46 degrees.
Yeah. So then that angle would just be 44, I think. The one, yeah, it's 44 degrees.
So you find the center angle 180 minus all this. How much is
Yeah.
it?
Yeah, 90 degrees. This is a 90-degree angle.
Again?
Yeah.
Again 90 degrees?
Yeah, it's a 90
Simpler
degree
things,
angle.
simpler for you.
Yeah.
Good for you. And 15 kilometers, right?
Yeah.
15 kilometers. And the bearing was 12 degrees. South, this is 12.
That's 12, yeah. So then we have to find the whole angle.
Find the distance between the ship and the boys at the
Yeah.
time of each sailing.
Yeah. You need this one. You need to find that angle C, like over there.
Yeah, we'll go to see vertically opposite angle. So this is vertical, this is
Yeah.
44, and this is 12. So 12 and 180 minus that, how much is left?
124.
180 minus 44 minus 12.
24 minus 12, yeah. 180. No, sorry, 124.
Minus 12. How much do you get?
124.
So this is 124. Actually, you can add 44 directly here. Because this line is
Okay,
there, vertical
yeah,
equal.
alternate. Yeah, there.
That gives you the total angle of
That's 56. 56. And then since you found that angle, you can just find another angle, and then you can just find the
yeah,
distance
yeah.
between
Now
the.
you can find both the angle, use sine and cosine.
Yeah, the other angle is just
This is longest side, that is 90 degrees, correct?
yeah, yeah,
You can do it now, right?
yeah. That's
So,
fine.
yeah. So now you know 56 is this angle. You can use sine cos
Yeah,
56 degrees will be equal to 15 over the hypotenuse,
over x.
which is we can say CP, right?
Yeah, yeah.
So
You
CP
should get
is equal to
28.82. Yeah,
cos of 56 degrees, correct?
yeah. 26.8 should be your answer.
So that's what you will get. And to find the other one, we can say it is 15 divided by, so this is a smaller side, correct?
Yeah, we don't even need the smaller side. We just need that side. It just says find
Both
the
sides.
distance.
Find the distance between ship and the boys at each of the
Oh,
tangents.
yeah, that's right. Yeah, that's right. So then,
You can
I
use
think
Pythagorean theorem also.
yeah, 22.2.
You can use
Should
Pythagorean theorem also.
yeah, you
22
could
plus
just use
8 means
5.
16 square square. Is it okay?
Yeah, yeah, yeah. That's fine. That's perfectly good.
So I think you have understood all the concepts, correct?
Yeah, yeah, yeah. I've got it now.
Very good. Can you summarize your learnings?
Yeah. So in this class, I learned how to do trig identities without spending too much time and just analyzing the trigonometrical identity and just making it easier for myself and just selecting the side that I think would be best to simplify from. And also, we covered bearings in different scenarios and what exactly a bearing is and how to solve these type of complex problems that you'd see in tests.
They were really complex, good questions, right? So,
Yeah.
okay, I wish you all the best and hope everything will be good for you.
Okay. Thank you very
Thank you
much.
and have a good night. Bye.
Yeah, you too. Good night.
These questions were shared by my student Aryan. I hope you find them interesting and useful. They actually cover the whole topic in a very beautiful way. Thanks to Aryan for sharing all these questions, and I hope many students worldwide will benefit from them. Thanks for your time and all the best.